You are live. So says the software. It can't be wrong because it's software. It's been programmed not to lie. I am live. Will anyone show up? Is the question. Live, unannounced, but I am at my regular time, so, you know, you never know. Will anyone show up? Let me copy. Fred Flintstone, first in the house. Mickle? Mikkel? Romaine? Greg? Graham? Wheaton? Copy, view on YouTube. Elikami? You were waiting. Excellent, thank you. Paddy, I guess it takes time for, you know, people to get announced or whatever and show up. But yeah, I forgot to pre-do this. In fact, I was supposed to get in earlier because, oh, hang on. This is kind of annoying at the moment. Let me, oh, there we go. Woo. There's a reason that I've got a lot of light under my chin. And there's a reason that I'm not looking into my webcam like I normally do, which would be over here, but I'm now looking into my Tegano camera. Well, I'm not, because my monitor's over here. It's all complicated. So if I can copy link address, okay, I'm just going to go on the Twitters. Whoa! Somehow that screen is zoomed out. Tweet. I'm now live doing a repair. Maybe. Oh, no. Hang on. Gave me the wrong link. There we go. It is tweeted. Therefore it exists. Because everyone knows if it's not on Twitter, it doesn't exist. It's Friday, crazy boy, is it? Ian Scott Johnson in the house. 10 p.m. tonight. Hang on. Oh, get rid of that. Good day, sir. Good night. 10 p.m. in London for crazy boy. Thank you, Douglas. I will remember that. I'm awesome. A live day of repair, maybe. How many results? Oh, I've had him from the survey. When I checked last night, it was yesterday evening. It was 1,100, I think. 1,100 results. I did post it on Twitter when I had like just under 1,100. I don't think it's so. It's not going to change the result much. What am I fixing? Hey, that's the best I can do. Sorry. It's the absolute best I can do. Yeah, I was doing a repair video last night. This is my what is it? A Aputure Amaran 672 or something. It is. This is my LED studio light, which has failed. Well, the light works. There, light works. But you'll notice that, there, get that light down a bit. You'll notice that those LEDs are lighting up. They are the charging LEDs. I don't have any batteries in there. I've got two of these studio lights, and yeah, it's flashing these LEDs as if the thing is charging. Although why the first LED's not coming on? Let me double check that. That could be an indicator. I should have thought of this. Hang on. Okay, all LEDs are on. I'm just gonna, no, it's not charging. Okay, I'm gonna have to leave that on for a minute to discharge those batteries. If I don't discharge those batteries, then they won't charge. So I'm going to discharge them for a bit. And yeah, I should have RTFM'd, maybe. But I just thought all the LEDs were coming on. But I seriously, I just know, like I've shot half my, interestingly, that one has a little plastic ring around it. That one's got a plastic, look, it's got a little plastic ring around it. It's special. Interesting. Anyway, that's the sequence it does when it's charging, right? But I'm thinking it might do all 4 LEDs. Anyway, right, the batteries are out. The batteries sit on the back here, right? And, oh, actually, I forgot to record this. Oh, what? Oh, hang on. Dumbass me, forgot my solid state drive because this is SneakerNet. My ATEM switcher here, I record all my stuff to my solid state drive here, but there's no way, even though this has got Ethernet interface, this is what I'm streaming over at the moment, isn't it? No, I'm streaming over USB at the moment. So I'm streaming out of the USB output of my ATEM switcher. And yeah, it's not doing the Ethernet. So yeah, it's USB. Anyway, even though it's got Ethernet connection, I cannot access this from my editing PC over there. So like it doesn't, like it can't appear as a network drive or anything. So when I'm done recording on this, I physically have to disconnect my solid state drive and SneakerNet it over to my editing PC, which is kind of really annoying. But anyway, if there's a way to do it, let me know if anyone knows. Hang on, I'll just check this. Wow. Okay, it's still not enough to charge it up. Still not enough to charge. Hasn't discharged enough yet to start charging. Which is strange. Of course I'm in shorts. It's summer. Summertime here in Australia. Have turned the aircon off, so it'll probably get up to like 24 degrees in here. Maybe 25, something like that. So, yeah, what bit rate does it record at? This is one of the annoying things about the Blackmagic ATEM switcher is that if you set it to like normal stream mode is like incredibly low bit rate. It's like 4 or 5 megabits per second or something. It is awful, right? And you can see the compression and you can see everything. And like I think I even asked Blackmagic and they went, oh, that's just the way it is. And I went, fuck, well, this is shit, right? I want to record the down mixed version and it's shit quality. And this is like a prosumer desktop thing. And they go, well, that's just the way it is. Maybe we'll look into adding variable bit rates. And then somebody clued me on to, no, what you do is you choose Hyperdeck. You choose the Hyperdeck setting. So I've got the Hyperdeck setting running at the moment. I can show you this. I have the tools, I have the talent. Oh, no, I can't because it'll show you my YouTube streaming key. No, better not do that. Anyway, yeah, so I've currently got it set to HyperDeck low quality, believe it or not. So it's, yeah, so there's streaming high quality, streaming medium, and streaming low quality in the HyperDeck thing. Actually, I can show, no, oh, you can, it partially cuts out the key. Hang on, I'll see if I can. Hang on. Sorry, this is boring stuff, but, you know, somebody asked, so blame them. Now you can still kind of sort of see my key, my streaming key. Anyway, yeah, even on streaming high setting, it was like 5 megabits per second. It was awful. So I'm now using HyperDeck, which is ATEM's their own recording system or something. So if I set to HyperDeck, even low quality, it's about 10 or 12 megabits per second. So it's really good. So that's what I record to. So that's what I'm streaming now. That's what's coming out of my ATEM and going into StreamYard. So yeah, that's anyway. Let me go back to. Yes, 5 meg is usually the best it gets for web streaming. Doug, yes, yeah, that's why they did it, because it's designed for streaming, but it also records that stream onto the SD card. And if I'm doing my, like, I shoot videos here, right? So I've got it all set up so I can switch cameras and, you know, do whatnot, right? I can switch over to my PC, and then I can go like this, and then I can turn on my multimeter on screen, and it's not quite there yet, but I can turn on my multimeter on screen. I can mix all this stuff live, so I don't have to mix it in the edit, right? So I want to record that onto my SD thing, but it's such a low quality. It's so piss poor. I ended up not using it until I discovered the HyperDeck thing. And even on low quality HyperDeck, it's you know, I think it's 10 or 12 megabits per second, which is plenty for a 1080p talking head Tagano microscope type thing. So yeah, it's good. So yeah, but that's just dumb. Why you can't set the bit rate? Like, you know, even on high streaming rate, it's awful. It's freaking awful. Yeah, they don't understand. I don't think they entirely understand what people use their equipment for. As a video blogger, I want to. The whole idea of having this huge mixing thing in front of me, this huge mixing desk in front of me, is so that I can switch cameras and mix everything live so I don't have to do anything in the edit. You know, and I should be able to choose the damn bit rate. Anyway, it works with HyperDeck, so I'm happy. But yeah, they couldn't tell me that. So yeah, anyway, that was annoying. So there you go. That's enough of that. Yeah. So anyway, yeah, I've got this thing. It's going. Maybe if I could turn off. No, makes no difference. So yeah, this is flashing. This is showing that it's charging. The batteries are not plugged in. The batteries are not plugged in. And my other one, if I take out the batteries and I plug the mains in the back, you know, a plug pack thing, then it does not do this. It does not do this. And it's killed 2 batteries. Like, killed them dead. Right? So something's wrong. Somebody before said, I bet you it's the diode. I bet you it's the diode, because you can see, if you look closely, there is a diode completely bodged across that battery pack there. But nope, I've checked all the diodes. I've already shot this as like a repair video, and I've gotten as far as checking all the diodes in here, and they're all fine. And I've identified these are all MOSFETs. So okay, so here's the 2 batteries, right? Battery 1, battery 2. These are all MOSFETs, right? N and P channel MOSFETs. So these do the switching, because the charging IC is all the way over here, and I can show you that data sheet. It's a consonant. It's a consonance. This Aputure Amaran light actually uses all these weird Asian sourced stuff, including like all the MOSFETs that you saw. These MOSFETs, they're all sino powers. Okay, so let me get that off. These are all sino power, and some of them have gate protection, some don't. That one doesn't. That one doesn't. But they use like these, which are near, you know, well, one's a bit more grunty than the other, but they're both P-channel, as you can see. And one, if you look at the schematic, internal schematic down here, one of them doesn't have gate protection, and the other one does. There it is, 8 kilovolts ESD gate protection, right? And maybe that's why they're using one and not the other. Don't know. But anyway, this is the lithium-ion charger chip, and it only supports one battery, right? So, as in 8 volts, right? So they've got 2 of them here, and they don't work. And you can't just plug in one, which is weird, right? Because like they must be putting them in parallel. They must be switching them in parallel with the MOSFETs that we see here, right? Because I've actually measured them, and they're not directly in parallel. So I can only presume that they're switching MOSFETs here. It's really hard with the black solder mask to actually you know, trace out the circuit and stuff. Only if I'm really desperate will I bother. So yeah, so this only supports one of the batteries, right? Which is one of these Sony jobbies, right? It's one of these Sony things. Yep, focus, you bastard, right? It's one of these NPF, but I've got bigger ones. I've got physically bigger ones, but they're exactly the same, right? And they're about 8.3 volts or something like that, fully charged or whatever. And this chip only supports one battery. So they've got 2 for some reason. So anyway, yeah. So these LEDs are showing up if I do the, oh yeah, hang on. All right. I am now recording. So potentially I could, if I find anything, I can use this in my repair video. So there you go. And yeah, so this thing is flishy flashing. Oh, this thing is flishy flashing when it shouldn't. When there's no batteries installed. And if I put the batteries in, it just kills them. Well, it kills one of them. On one of the channels, it kills them. So yeah, and the voltage without the batteries in, the voltage on the good one is 8.3 volts across here or something. It's 8 point something volts, right? On these ones, it's like 0.9 volts, right? So something's going on, right? Something's wrong. Something strange is afoot at the Circle K. Name the movie. Name the movie. Movie trivia question of the week. Something strange is afoot at the Circle K. Can anyone get it? Can anyone get it? Come on. First person to get the movie reference wins the internet. It ain't Ghostbusters. Bill and Ted's Excellent Adventure. Michael wins the internet. Bill and Ted. Yep. Electronic Smoke got it as well. Yep. Can someone please inform the latecomers what we're fixing? Anyway, so yeah, it's really strange. And I didn't tell you before, but the micro, hang on. The micro is this one, a SyncMOS. Who has ever used a SyncMOS processor? SyncMOS Technologies International. Yeah, that is the micro used in this thing. So yeah, these Aputure lights, these Aputure Amaran lights, they really like using these weird Asian source parts, even right down to the micro and the charger chip. So yeah, I haven't looked at what it's also got a wireless function as well, but I haven't looked at what the chip is on the wireless function. It's probably, once again, it's probably some obscure brand you've never heard of. Anyway, there's nothing wrong with the electrodes. Nothing wrong with that. So, yeah, there you go. So what I can do, what I was going to do is... let me know, scream it. Thank you. JP Vault developer. You know you're in the right path when you find a Chinese datasheet. Yeah. Yeah, you're lucky. You can actually, I don't really have too many problems getting, if they've got some obscure Asian part, I usually don't have too many problems getting the datasheet. It's, yeah. Is there anything else across the battery? No, I don't know apart from the diode, but the diode measures fine. So, and I can prove that to you. I'll prove it to you live because nobody believes me. Nobody believes me, do they? Right. Watch this. I have the tools. I have the talent to show you this live. Watch this. Look at this. I have a multimeter. I have multimeter probes. And yes, I am in diode mode. Get the probes around the right way. And oh, this is powered. This is powered on. So yeah, probably should. Oh, no, it's off. Right. Whoa. Okay. Yeah, it's off, but it's still going to power through. Meh, whatever. I don't think I'm going to blow it up. But I don't expect it to work. Nah, there it is. That's the 0.9 volts I was actually telling you about, or negative. There's the positive. Yeah, there's the, even though it's in diode mode, it's actually just working as a voltmeter now. So it's, yeah, there's that 0.9 volts I was telling you about. So I'd have to physically, hang on. The thing is, you can't just, there we go, I killed it. I killed it. There you go. 0.6 volts. All right. 0.6 volts for the diode. Put it the other way around, and she's open. Some of the other diodes, these are shotkeys down here. I think I've got that the wrong way. No, there we go. They're 0.14 volts. They're shotkeys. There. Which is a dead giveaway because they got SS on them. So, yep. Anyway, yeah, so the diodes are, like, I thought, you know, that diode bodged in there. I thought, you know, you little bastard, right? Look at that. That's just complete bodged, right? Isn't even a pad there. They've just put that on as an afterthought. And it's only on the lower battery, right? So I don't know what's going on there. But yeah, I reckon that they're paralleling these up. So, yeah, one of the FETs. Yeah, I know. It's like, yep, it's probably one of the FETs, which is dodgy. Would be my guess. But what I want to check now, what I want to check is, let me go back to, boom. Oh, it's still put, hang on. Oh, no, it's all good. Right. What I want to do is, I'll power this back up. Hang on. It's really difficult because this thing is, it's all, the wiring is all kind of how you're doing, right? Okay, so, well, that, by the way, is the absolute wimpiest force crocodile clip I've ever felt. completely wimpy. I have checked that that is ground. That goes off, you know, you just check and just buzz from there to, you know, the nearest cap or something. And sure enough. Hang on. Oh, damn. Problem with all this is, like, I've got my soldering irons here, and, like, I've got probes coming out of my thing, and it's all mixed up with my soldering iron probes, and it's all a bloody mess. And that does not spin. That does not spin. These are the probes which came with the virtual bench, which is what I'm using here. Is a national. Oh, sorry, couldn't see any of that. Couldn't see any of that. Yeah, the crocodile clip, wimpiest one I've ever seen. Sorry, and it is ground, which goes over to here, and yeah, and this I can't bloody well rotate that, which is a stupid pain in the ass. Yeah. So anyway, yeah, these are the probes which came with the NI virtual bench. Anyway, so what I'm going to do, sorry, I can't get up, and I don't know how to do it because I don't know. Is there a way for those ATEM switcher experts? I've only got two stream keys or whatever they call it on the ATEM switcher. So that means like stuff I can overlay, and at the moment I've got like I can overlay the multimeter on there, which is just I've taken a screen capture and then I shift it up. So I've got that set, but I'd like for in this view to be able to have the oscilloscope and a second camera, Like my talk, I still like to keep my talking head and have yet another camera, which I can have a B cam. I've actually got a gooseneck for a B cam, but it's got a light on at the moment. But I usually have like a second B cam on there, and I don't know if that's possible. I still don't understand the ATEM switcher. Like it's just I just can't wrap my bloody head around it. So, yep, somebody said I had a wrong camera. Stop preparing giveaway Keysight stuff. What? It's the FET for sure. Yeah, people think it's the FET. Yeah, I probably think it's FET. Anyway, I am going to probe. So sorry you can't see this, right? But I'm going to probe the inductor, which is part of this charging chip. So these two diodes, if you saw this schematic before, okay, so I'll show you what I'm doing. Show you what I'm doing, right? Here's the schematic, right? This is the charger chip. And so I'm going to probe this inductor, right? So I'm going to see if there's any switching action happening on the inductor here. But that wouldn't explain why like it's draining the battery. So that's why I think it is one of the FETs gone. But just as a matter of course, I do want to check that. So yeah, here we go. So what do we get? Nah, that's probably what volts per division am I at? I don't hardly ever use this. Where's my volts per division? It's not saying 165 millivolts on the max. 1 volt per division. Okay, yeah, so that isn't the 0.9. Hey, hello. Whoa. There was switching there. Yeah, there is. There you are. Yeah, so it's switching. So the light's actually switched off at the moment, right? So it's in like off mode, but the charger chip still works because it charges the batteries when you switch the light off, right? So yeah, so that charger chip is switching. So it's doing its business, right? It's doing its thing. So no wuckers. That's across the big cap there. I don't know what that is. So that's a volt per division. So that's only 1.5 volts, right? So, yeah, sorry, yeah. I wish I could show you like all three things at once. I could probably do, I could get rid of my head. I could do it manually now. I can get rid of my head and I can overlay my Tagano onto the oscilloscope, but yeah. Or I could have the Tagato as a main view and have the oscilloscope pop up as a thing. But I don't know how to, like, I can do it, but I don't know how to automatically have it set up so that the buttons do it. And I can just like switch in. So the DVE overlays on the ATEM switcher, I can manually adjust it, but I've already got it set up, so you can see that my multimeter overlay is there, right? So I can switch my multimeter overlay off and on. But what I'd like is to be able to have another picture-in-picture overlay, which allows me to choose between the multimeter, which captures the bottom half of the screen, the bottom strip, and just moves it up to the corner, and the waveform one, so that the waveform could be down in its own window. So I'd really like to be able to do that. Yeah. What software am I using for the overlay? It is not software. It is a JP Vault developer. It is a Blackmagic ATEM switcher, and I've done videos on this. It's a big switcher. I could tilt the camera down, you know. Google Blackmagic ATEM Mini Extreme ISO. So if you go and Google that, you will get it. So yeah, it's just really annoying. Like, I'd like to be able to have like all these multiple things, and I can do it manually. I could go into the ATEM switcher now, software now, and then I can manually configure it so that it captures the waveform and then moves it down as another overlay window, like, or as a, but then it screws up the multimeter overlay. So it's like, I'm just not smart enough. I cannot figure out these ATEM switches. They're just so complicated, and they use all these, like, you know, you have to be in the editing video, the live broadcast industry. You know, you have to use these things every single day for 10 years to figure out what all of these things, what DVEs are, and internal mix buses and keys, and, you know, like, I just don't get it. Yeah, these things are not designed for a dumbass video blogger to use. They're designed for industry professionals who are used to using, who are, you know, have been using broadcast switching gear for 30 years, right? And they're just, they're absolutely no good for your regular video blogger. I'm sure it can do it. I'm sure there's probably a way to do it, because I've got like the high end. They sent me the high. They took pity on me and they sent me the high end one that had 2 different internal keys, so I could do like multiple overlays like I'm doing now. But I still don't know. I kind of know how I've set this up, but then if I switch, like it's auto vanished, right? You'll notice that the multimeter's auto vanished from the top if I switch that. But if I go to my B cam, which I don't have hooked up, it's black, then the multimeter appears. Then the multimeter doesn't appear if I go to my Tagano microscope. So then I've got to switch that on manually. And this is like, you know, transition effects when you go from one to the other, but it's always changing. And I do not understand, like, and it's gone now, but then I can switch my multimeter over that. And so I've kind of brute forced it to do mostly what I want, but I still don't understand how it all works. It's so embarrassing. So embarrassing. You're in the broadcast industry, Douglas. I do this. I will help you. Thank you. But yeah, you've got to know the ATEM switcher software. So yes. So I would like, you can't see it. Yeah, so I would like, yeah, I just want all these multiple things set up. And there is a limit. I think I'm actually at the limit at the moment with my, I've got 2 overlays. I think that is technically the limit. But I would like to have the ability to hit a button somewhere, I don't care what it is, hit a button somewhere, and for it to swap from the multimeter one to another type. All while keeping my talking head and the background. Is that possible, Douglas? I don't know. Like you have to know the Blackmagic. You don't. Broadcast knowledge isn't enough. You have to actually know the capabilities of the Blackmagic Mini Extreme ISO Pro. I think it is Mini Extreme ISO. Yeah. You have 2 overlays, but you can reprogram them and save them all and recall them anytime. It's called a macro. Okay. I need to look into macros, do I? See, I haven't set up... See, I have never seen mention of macros in the ATEM. Like, I'm inside the ATEM switcher software at the moment. I can't show you, unfortunately, because it's got my YouTube streaming key. Actually, hang on. Oh, I just killed my stream. It's okay. I don't YouTube stream from here anyway. Anyway, I've killed it, right? So I'll just leave it. Here we go. I can now show you. Right? So this is my Blackmagic control software. All right? And somebody asked about the streaming quality before. There you are. Right? Streaming high. Oh, right, yeah. So I normally have it set to hyperdeck low, right? And that gives me the much better quality than streaming high. Streaming high is not good enough for my simple talking head needs. It's so piss poor. Anyway, so media players, palettes, output. No, hang on. Hang on, maybe it's different because I'm recording. Yeah. Here it is, palettes, right? This took me for, oh no, you probably can't see it because my talking head's over it, right? But this is called palettes, okay? For some reason, all this overlay stuff, well, all the overlay stuff is called DVEs, okay? They're called digital video editing or something. I don't know. Digital video editing, I don't know, visual editing or something. They're called DVDs, and they're under. See, I can't even move my talking head now, and I can't even switch my talking head off, right? Because I've got my talking head. This is talking head, and this is on, and it's like, I don't know. Anyway, I can change it, right? Because here is the fill source, right? So I've currently got, in this mode, PC screen, okay? And then if I go down here it is, yeah, sorry, these are called upstream keys, right? These are called upstream keys, right? So these overlays, so this is my upstream key, right? So if I change from Dave to Tegano, you'll see my head disappear now, and you'll see the Tegano microscope. Watch. Ta-da! Right? So I've figured out this much. And I've figured out how to move it, right? I've got all this stuff set up here. So this is like, if I adjust this, I'll be able to move my talking head around, right? So I've got this. So yeah, it's called a DVE, right? So it's under DVE, but this is under the palettes menu. If you, like, what? It's just madness, right? I'm sure people who are, ATEM switching experts are just, screaming at me, but it's just awful. It's just, and I can mask it, and I can do shadows, and technically I can do green screens by doing chroma keying and stuff like that, right? Oh, my head's gone. Hang on. Oh, see? Now I'm completely gone. Hang on. What? See, now I've completely ruined it. I am switching. I am switching my camera It's supposed to do this. It's supposed to switch my camera. It's not switching anymore, right? I can't get talking. I've just killed it. Thank you, Rasenbot. Thank you very much, Rasenbot. You swap the outputs, okay? Yeah, you accidentally full screen key 2. Yeah, well, friggin' hell. Oh! There it is, it's back. Oh, so just changing the tab. Just going in there and playing around with the tab. Oh, I get it. Oh, wow. So I can't go in there and just play around with this live. Like the upstream key, I can literally choose DVE, pattern, chroma key. So I can do a weird ass pattern there. Like I can do I've got a weird mix, right? I've got weird mixing stuff happening over here, right? So I'm blending, right? So I'm blending in a triangle shape. I can do a rectangular shape. I can do a circle in the middle like that, right? I can do a square. Right, so this is doing it live. Okay, and then a chroma key in, which I don't have a green screen. And then I've got Luma, right? I don't know what Luma is. Pre-multiply key, media player 1, media key, fill source and key source, right? It's just, Focus on the electronics, let's do this later. No! Damn it. Defpom, sorry, what was your previous comment? I have no idea. Sorry. Yeah, it's just maddening. Maddening. Trying to get, like, I've now got it set up and I've got it preset. So when I power it on, it just does what I want. Mostly. Thank you, Douglas. It's freaking painful. It really is. Anyway. Yeah, see, it changes the type of key, right? See, that means nothing to me. I don't know what the key is, right? Yeah, okay, it changes the type of key. I just do not understand what these things mean, right? Yeah, I don't know what you can do by simply telling me. It's like I've had people try and tell me before, and actually people eventually clued me on to, oh, you've got to go into the DVE thing, and that's where you can, change it, and I managed to finally do it. Key is cutting out things from video. Okay. Yeah, but why is then? Yeah, but why? To me, it's picture-in-picture overlay. That's what it's called. Yet on this, it's a key. Anyway, what was your, sorry, Defpom, what was your thing? What was your comment that you wanted me to look at? I'm trying to go back. My guess is the charging IC itself. Bypassing the MOSFET and series diode to connect the battery charger supply and the leakage to 0 volts. Yeah, but how does the charging IC bypass the MOSFETs? The MOSFETs aren't under the control of the charging IC. I think they're under the control of the micro. Right? Look, right? Here's the charging IC. Okay? This is the charging IC. That's the inductor for it. This is like a switching charger. This is the inductor. These two must be the diodes going by the application note. This is the current sensor, right? And then you've got all these MOSFETs around here. The charging IC does not. The charging IC. Oh. The charging IC does not control MOSFETs in any way, right? Well, it controls the drive MOSFET, okay? It controls the switching MOSFET, but we're seeing that that actually switches, right? Because we actually get a switching waveform on the inductor here, right? So, well, I guess no. Well, or is that coming? No, CSP. Okay, no. So we're getting a switching waveform there, right? I've checked that inductor. We do get a switching waveform there. Okay, so I reckon it's not. I reckon the charging IC is fine. Thank you, Abdul. Sarko, what's going on? You missed all the fun. This is the number on the charge IC, CN3702. It's on screen at the moment, CN3702. This is it here. Consonants, 5 amps, standalone lithium-ion battery charger, right? And it supports 2-cell lithium-ion batteries, which is what I've got, which is what these Sony ones are. But there's 2 of them, and it won't work with one. And I'm not talking about the faulty one. I'm talking about the good unit. Oh, have to go check the good unit. Oh, it still hasn't gone down a bar yet. Will it charge? Hey, it's charging. No. Whoa. Okay, hopefully you can hear me. There is no charging LEDs. The first LED, the LED on the left-hand side, flashed briefly, multiple times. Wow. Okay, no, I'm going to have to leave that on. Or I could, maybe I could put in an already no, I don't have already discharged batteries, I don't think, apart from the dead ones. Yeah. Anyway. So yeah, what was I saying? So yeah, the charger chip is doing switching, right? So is the sense resistor done? No, I did measure the sense resistor. I did measure the sense resistor there. And it was its 0.1 ohms or whatever. No, the see, that's the thing. How are the charging LEDs getting powered? Well, these are the micro, right? These LEDs here. Sorry, it's hard to, the lights. Yeah, the LEDs here. These come from these don't come from the charging IC, right? The charging IC doesn't have any ability to do charging LEDs. Hang on, does it? Let me. No, it does, right? So the LED, the charging IC does have LED capability, but it doesn't have a LED bar graph. Doesn't have a LED bar graph. So all of that, so the flishy flashy down here, right? This is done from the thing. Actually, can somebody look up? Can somebody in the background? Can somebody look up the manual for the 672 for the Aputure Amaran 672C, I think it is. Have a look up the user manual, see if it's got any like error codes that these 3 light up, because I don't know why this one doesn't come on. That's really strange. Right, so, and then if I turn it on, right, actually this LED could be dead, because not, oh, whoa. Whoa, hang on. Hang on. Let me turn that off again. I'll show you. Show you what it does, right? Right, it goes three LEDs charging, and then 3 LEDs solid, and then wait for it, there, 3 LEDs go. The other one does 4 LEDs, right? The other one, oh, no, but this has no batteries. Okay, so the first one might be like a separate indicator LED charging, something like that. Oh, sorry, couldn't see it because the bloody comment was there. But yeah. And go. Yep, and it flashes. Thank you, Heinrich. What voltage it actually charges the batteries? 8.3. On the good one, I said this before. It's what? We can't see Dave. Yes, you can. I know you can see me. Hi. Thank you, Andrew. He looked at the manual, nothing about error codes. Yeah, I thought there wouldn't be. I thought there wouldn't be, but thank you for checking. Yep. I was pretty confident there wouldn't be. I have no idea if there's a firmware update. No. Yeah, but when it kills the batteries, when it actually kills the batteries, nah. And both of my lights are the same, right? Bought at the same time, so they have the same firmware. They're doing different things. Seriously, when I switch this off and I have no batteries connected, like in this one, this bar graph is off. It does not do that, okay? So it's like, this micro seems to think that it's charging, right? The micro seems to think that charging is happening because the bar graph happens, but I think it's I thought it was 4 LEDs. So I still don't know about the first LED, but that bar graph action is exactly what happens when you have it switched off like I have now, and you have the batteries in there and it's charging, but there are no batteries on the back of this. So yeah, and the other one doesn't do that. And this one kills batteries. I've killed 2 batteries, like completely dead. They're at 0 volts now. It's completely neutered them. At first I thought that it's not, like, at first I thought I just bought, because I've got these off-brand batteries, right? They're actually decent brand. I've used them before for other things. They're okay, but they're not genuine, right? They're not genuine Sony. So I thought, okay, look, lithium-ion batteries, you can get dodgy ones, right? So I thought I've got a dodgy one. So I ordered another one. And then I discovered that yet another one died. And then I figured out that, then I paid attention to it and realized that, yeah, bloody thing is killing batteries. So, yeah. But it works fine. The actual light works fine because it can just bypass the batteries. It just bypasses them. If you don't have them in there, or even if you have them plugged in, it'll simply bypass them as well. So yeah, but I'm waiting for that thing, waiting for that light over there, that light there to bloody drain a bit, so that I can see what the LEDs do when it charges. I'm pretty sure it's all 4, but maybe I'm wrong. Maybe the first LED stays on. Maybe this first LED stays on. I'm pretty sure it's all 4. But maybe the first LED stays on and then it only does the 3. So this LED here may be indicating something. The fact that it's off. I don't know. Strange. Yeah. It is exactly what it does when it's charging. Yet there's no batteries. No, see, I don't think so, Fred. Right? This is what DEFPOM... Oh, did DEFPOM ever reply? Did anyone see if DEFPOM replied? So if the sensor resistor is okay, the charger chip must be the problem. I don't think so, because the charger chip is switching. It's doing its switching, right? And if the charger chip was at fault, it just wouldn't charge, right? You would think, right? So I think there's something fishy going on with, like, because they've got lots of MOSFET switching in here, right? There's lots. There's 5 MOSFETs just in there. There's another one over here. There's another couple over here. Like, there's like 8 or 9 MOSFETs in this damn thing, right? They're all over the place. It'd be an interesting schematic, I think, to actually see this. It'd be interesting. And it's not easy to reverse engineer because of the black solder mask. Pain in the ass. Can hardly see the tracks. Yeah, so I don't think it's a charging chip because the charging chip is switching. And I bet you that frequency we measured before, we saw that waveform, I bet you it's the 380 kilohertz that the data sheet says, right? So if it's switching, it kills the battery. Yeah, it's some sort of, oh no, it's some sort of drain. I think it's some sort of drain. So I could probably get a current clamp. I can probably get a current clamp and put like a battery on here. Have I got enough room there for a current clamp? Yeah, probably, a small one. I could get, I don't generally use current clamps. Got one somewhere. I've got the, of course I could do the ATEM iProber, ATEM, the TTI iProber. I could drag that out. It's up on the shelf, but then you've got to plug it into the oscilloscope, and then you've got to set it all up, and you know it's a bit of a. So yeah, if I have to for the video, I will. But just buy some new lights. No, damn it, because the lights work fine. Like, you know, they work fine. It's just that it kills batteries. So, and I mostly use them without the batteries. Like I just have the batteries in there. If I need to move them, then it's handy just to be able to, you know, use the batteries. Yeah, I think that the MOSFET, I think that they're switching the cells in parallel. But the interesting thing is, even on the good one, if you only plug in one battery, it does not work. It needs 2. It needs 2 batteries, right? Yet the charging chip is not capable of charging 2 batteries in series. It's not capable of it. And there's no other charging chip on here. Unless I'm Stevie Wonder, I can't see it, right? There's no circuitry on the bottom of the board. Yeah. So this one is very unusual. Yeah, I think the CPU's being fooled, Pierre. Yep. The CPU, which is obviously working, right? The CPU's down here, it's working because it does all these, right? It drives these LEDs, clearly, right? So it's getting some power, right? These MOSFETs up here, one's the switch. Here's the switch. Here's the power input like this, and it switches and it just bypasses, like the lights are off, but the LEDs are off, but the charging circuitry stays powered up and the micro stays powered up. Even if, so this is basically a soft switch. Basically a soft switch. So, but I think what the soft switch does is physically switches another MOSFET, which then applies power to, you know, all the rest of the circuitry, right? But the micros got to be powered from the same supply that the residual charge is being powered from. So there's actually some power supply stuff up here, so I don't know how don't know what that's doing up there. But yeah. There's another current shunt resistor down here. Don't know what that one's doing. These are MOSFETs. Sorry, this is a switcher. This is a switcher for this DC to DC converter here, which I believe powers the current shunt, which powers the constant current drives, powers the three constant current drivers down there. So that's that switcher there. But these are all MOSFETs. These are all MOSFETs, all of them. Down there, there. I think that's a MOSFET as well. 2 more MOSFETs up there. MOSFETs everywhere. The charging chip can charge 2 batteries in series. The thing with that is ta-da! The battery is actually 2 cells. Focus, you bastard. Come on. You can do it. You can do it. You know you can. Here it comes. Here it comes. Wait for it. 7.2 volts lithium-ion battery pack. So it's actually a 2-cell pack. It's a 2-cell pack, which is exactly what the charger chip charges, right? But if you get 2 of these packs, you've now got 4 cells. It can't do that. This charging chip physically cannot charge 2 of these in series. So they must be in parallel. But you can't just use one. You can't just plug in one battery. It needs 2. I don't get it. It is dumb. It is completely stupid. Oh, Paul's in the house, is he? He's been going. It'll probably happen sooner than that. Lol, what's happening? I'm giving Dave another 20 minutes before he bans everyone in a rage quit from all the helpful hints. Yeah, helpful, but they're wrong, right? The charger chip I've shown you, here it is. The charger chip will not charge 2 batteries in series, right? I don't think you're aware of the circumstances. It will not charge 2 batteries in series. So therefore, they must be in parallel, yet it's blah, blah, blah. Yeah, it's, what was I saying? But it won't work with only 1 battery in there. It's dumb. They could be, Colin. And so, yeah, people are saying it's the charging chip. I don't think so. The charging chip's switching. It's doing its switching, okay? So there's MOSFETs after the charger chip. That's what's happening. And I think they're controlled by the micro. So yes, I think, Colin, yes, they are using the charge lead from the charger IC as an input to the MCU. That is likely. And then doing smart stuff to detect battery voltage and displaying bar graph. Something like that's happening. I think because the charger chip does not have the ability to switch external MOSFETs for battery packs, right? It does not have that ability. It must be being done by the micro. It has to be, right? Unless there's some other discrete circuitry on there that's doing it. I mean, like, I doubt it, right? So I think the micro is doing this. See, but the thing is, right? If the charging chip was dead, or the charging chip wasn't enabled, or some other thing wrong with the charging chip, why does that kill the battery, right? Why does that kill the battery? Okay? I think what's going on here, okay? Here's the charger chip, okay? It's doing its regular charging thing. This matches the application note, okay? We've got the switching inductor. We've got the switching diodes here, okay? And then after this, we've got 1, 2, 3, 4, 5 MOSFETs around the batteries, okay? And the charger chip has no ability to control those MOSFETs. And the batteries, at least one of them, I think it's this channel. I think it's this channel which is being killed, the battery on this channel, right? So it is discharging those batteries. It's doing something bad, right? There's some, I don't know, shorted, dead MOSFET or something like that is my guess. Tell me I'm wrong. It could be monitoring. No, the this here is monitoring the output current, the charge current, which is that's being controlled by the charge current's being controlled by the charge IC here. Okay. I can't. I can't. It's hard. If I do this, if I move this up too much, it overlays the buttons on my ATEM and accidentally hits the buttons on my ATEM switcher. It's really difficult. Sorry. Yeah, something like that. Yeah, the two batteries are switched back and forth between the control of the charger. Yeah, probably that they might charge, you know, they might switch it over, but it's got to be the micro doing that, right? It has to be the micro. So the micro is probably getting like the charge output, you know, charge complete or whatever from the charger chip. It's reading that, and then it goes, oh, okay, let's try and charge the other battery now, and boom. But see, but the thing is, right? The thing is, these lights will not work with one battery. They will not work with one battery. You need two batteries for these lights to work at all. It is stupid. It is so stupid. Look, I can show you that now. I can show you that now. Light is on. Light is on. No mains plugged in. If I remove one of the batteries, or is it going to make a fool out of me? No, see? Turns off. Right? These are full batteries. The lights do not work with one battery. And there's no master channel that I'm aware of. Oh, these battery clips in these are so shit. Take out the other battery, it dies. You've got to have two batteries. Right? Got to have two batteries for that. Gee, it's still showing all bars. There we go. Yeah, it's charging. Hey, it's charging. All four LEDs. All four LEDs. LEDs off, all four LEDs off, and then the first one, second one, third one, fourth one. Right? Yep. Cool. Got it. Got it. There you go. See? You can see how I'm not dealing with a simple lithium-ion battery charging system here, right? There's something weird. There's weird switching and shit happening here with these two batteries, right? Why doesn't the product work with one battery, right? If they're in parallel, which they should be, right? Well, by parallel, I mean, you know, like it can't charge two in series, right? So if they're both in parallel, or it switches, but why can't you power the product from one? It's a bizarre design. Yes. Yeah. My next step was going to be do the MOSFETs. Yeah, it was. So, kill it dead. So yep, I'm going to see if a MOSFET is permanently switched on. Ta-da! I mean, the thing is, if I wasn't using the live stream, I would have done like all the stuff I'm talking about here in 10, 15 minutes, you know. So I don't think I'm going to use this live stream footage in my repair video. Which I've already shot. I've already shot and edited like the first half of the repair video, which gets me up until this point. And yeah. So do the ohms range. Here you go. These the problem with these Fluke, these very sexy TL, I think they're TL17. Sorry, these are Pomona. I thought these were Fluke. These are Pomona. I thought these were Fluke TL174s or something. Look, right? They got really high contact resistance, really high. It's just so annoying. Right, but they're really sexy because they're pogo pins and they're really fine. So, yep. Anyway, yeah, MOSFETs. No batteries, no power, no anything. Yes, I just showed that, Nussacat. Maybe your comment came before. I just physically demonstrated that over there. The working unit, perfectly fine, does not... These lights have never worked on one battery. Maybe it's in the manual, if you read the manual. Yeah, my next thing would, yeah, I mean, you know, there's several ways I can attack this, right? If it's draining the battery, there's several ways to, oh yeah, I'm way behind on the comments, sorry. Yep. Yes. So yes, BatTube. Yes, and others that have mentioned that. Yes. Yeah, my next thing would have been, well, probably, you know, my next step was going to be like I would check the MOSFETs, because I'm pretty sure that switcher is fine, right? So I'd measure the MOSFETs, make sure they're not shorted, and then I would get out, and then I'd plug in some charged batteries and start trying to figure out what's heating up. Yep. So anyway, 500K, not shorted. Hello. Ding-a-ling, ding-a-ling, ding-a-ling. 1 ohm, 1 ohm, 1 ohm. Ding-a-ling, ding-a-ling. Yeah. No, that's... yeah, that's physically open. This one here is a MOSFET as well. 33 meg. Yep. I don't know what these ones over here do, by the way. Like, they're just like so out of the way, you know? I don't know, maybe that's the one that maybe like the output of the charger's here, and then these go into the output of the charger here. And then it switches, which battery. Like, but like there's MOSFETs all over the place. I'd love to see the schematic for this thing. It's really weird. It's really weird. And I just don't understand the functionality. I don't know why you would design a product like this that has two separate batteries that obviously aren't in series. I can understand if they're in series and you need the high voltage, whatnot, and you charge them both in series and they've both got to be in there. That's fine. Okay? But when you've clearly got a charger chip that only supports one battery at a time, why you would not have, and you include all this, go to the effort to include all this MOSFET switching capability, why you would not include the ability to operate this thing from one battery? I don't understand. Can somebody in the comments please tell me why you would do that? They steer the batteries so that they're in series. Yeah, that's the only thing I was thinking. That they needed the high voltage, yet they charge it at a low voltage. Like they charge one cell at a time, yet if you power it from the batteries, it actually needs both on. You know, yeah, that's you know, I was thinking that before when I was over there. That was kind of like the, yep. In the old days, you had to plug a cable and a 500-watt bulb for a film light. Today, it's a bit more complicated. Yeah, yeah. Yep. Maybe one battery is not capable of delivering the power needed. No, I think one battery is more than capable of actually delivering the power that's needed. I think it's a voltage thing. I think it's a voltage thing. Yet they've decided to add all this complex switching in there so that it charges one at a time. Charges one at a time. Yet, if you power the thing, it'll switch them in series. Maybe there's no intelligence doing that. Maybe it's just like, if there's no power coming in here, right? If there's no external power and you plug both batteries in, then it switches on a MOSFET which joins the batteries together or something, and then that actually provides power. But then when you go to charge it, it charges one at a time. So maybe even the grounds are floating and they're switching them. Yeah, yeah. So yeah, that's my best guess. Yes, yeah, Johnny, yeah, that's exactly what I just said. Yeah, maybe it charges them in parallel, then series them to run the battery. Actually, I don't think it charges them in parallel. I think it charges one and then the other. I think, maybe. Although they've got enough bloody MOSFETs in there. Got enough MOSFETs in there to run a computer, turned into a computer. You know, it's got enough bloody switching MOSFETs, just crazy. Yeah, yeah. Anyway, so yeah, so my memory was correct. The good light over there, the good one in the background there, those 4 LEDs. Thing. Anyway, we might have found the culprit. We might have found the culprit. It might be. Let's measure this again. This MOSFET here. Oh, hello. Look, 0.9 ohms. 0.9 ohms. Right? There it is. There's the bastard. There it is. That's a 4803. Okay. Oh, sorry. Blah. Blah. That's a 4303? Is it a 4303, is it? No, that looks like a 4803 to me. Oh no, that's 4303. Is it? I think that's a 3. Hang up. Put a bit of spit on it. That's a 3. There was a little there's a little thing on there which made it look like an 8. 4303. Yeah, there you go. So that is a 4303, right? And I think we found it. So if this is it, then what you're going to see in my final repair video is none of this live shit, which is just me yapping on. It'll just be me jump into, well, the next thing after measuring the diodes is measuring the MOSFETs to make sure they're not shorted. And then I might include that explanation I just gave of how this thing works, because it's really weird. Look at that. Can anyone come up with a reason why that should be 1 ohm in circuit? Actually, yeah, either give me a reason now in the comments, give me a reason why that would be 1 ohm in circuit, or press F in the chat. Press F in the chat if you think that that's dead. Do we have F in the chat? We're doing a snap poll. F in the chat, or F for failed, or give me a technical reason. F. Everyone thinks it's failed. I might include this in my live show, in my final repair video. Reverse leads. Reverse the leads. F. Everyone thinks it's F. F. Oh, look. I will. Hang on. Whoa. Here we go. Everyone in the chat. Everyone in the chat seems to think that this is failed. I asked everyone to press F in the chat if they think the MOSFET's failed, and it's failed. By engineering consensus, that MOSFET is kaput. Dead. Got it. Boom. There you go. So, yep, that is a P channel. Yeah, that's the P channel, isn't it? The 4303 or whatever. I'm pretty sure that's P channel. Yeah, 4303 Yep. So, oh, that one, see, that one's got the ESD protection. That's what killed it. Don't trust MOSFETs with ESD protection built in. Reliable and rugged. It's reliable and rugged, folks. It's reliable and rugged. There it is. Apparently not. Yep, it's dead. So it looks like I'm going to have to try and find a replacement 9 milliohm, 10 volt VGS, 30 volt rated MOSFET. Something like that. Or, it depends on what VGS it's being used at. If it's only being used at 4.5, then, 15 milliohms or whatnot. But, yep, that's it. I reckon that's the culprit. I reckon she's died. Does anyone disagree? Actually, there were some tunnel vision. Not failed. It's the components in circuit doing that. Jason, tell me which components are doing that. Tell me the topology. That's giving me 1 ohm. 1 ohm. Hey, Kerry. Yeah. Of course, if I suck it out, I will, yep. Ernie, stop. I did check the other MOSFETs. It's not failed, it's just resting. Yeah. I do have a MOSFET kit. So I could have a look. But, it won't be an exact replacement. It'd be, Can somebody search DigiKeys and Mouses and Farnells? Probably, preferably Farnell here in Australia. Element 14, whatever they bloody call themselves these days. Can somebody search for that part? Can somebody search for the 4303? I don't care which manufacturer it's from, assuming there are different manufacturers. So, yeah, I did check the other MOSFET. I did check it. So... Hang on. Give me my multimeter back. Thank you. Yeah. Somebody wanted me to swap the leads. Okay, I'll swap the leads. Hang on. It's easier if I watch the screen because this is... Yeah. There you go. 1.2. You have to remember that these probes are dodgy, right? These they're great probes, but they're incredibly high and unreliable on resistance, right? So unfortunately, this is not the right probe. 1.2. There you go. Both ways. Look, I'll get out my BM786. Okay, sorry you can't see it, but that's 0.12 ohms. 0.12. Oh, 0.33. 0.33. And the other direction? So we're talking 0.2 ohms. Wow. 0.35 the other way. Yep, it's failed. It's definitely failed internal, no doubt. Yep, it's Gonski. Wow. There you go. Should I remove it? Should I remove it? Yes, everyone's saying yes. Why don't I do a MOSFET repair? Okay, I'll just put some fluxy on to help it along. Oh no, I was going to say, is my flux pen dead? Can I get, is that too close? Am I going to get my tweezers? Yeah, I'm going to get tweezers in there. Okay. Yeah, no worries. All right. Let's see if we can get it. Got it. Got him. Oh, sorry. I'll leave that. Oh. There you go. Got him. Okay. Sorry, I'll try and get this on on camera here. Yep, I will test it now. That's the plan. Okay, odds. Give me odds. Give me odds. Odds in the chat. Odds in the chat of whether it's shorted or not. "50-50", says Mike. 100% even money. 100% 99, 100% 9 to 1. The bench is shorter, giving false readings. Oh yeah, these dodgy ESD dissipative mats. All right, here we go. Oh bloody hell! It's really hard to see this. Ta-da! 1 ohm. 1 ohm. Oh, sorry, you can't see that I'm not playing funny business there. Oh, it's, yeah. Anyway, trust me, that's 1 ohm. Oh, I'll double check with my Bryman again. See if I get that 0.3. Sorry, 0.2. Well, it was saying 0.3. Yeah, I'm getting 0.33. There you go. 0.33 ohms. Got him. Yeah, failed MOSFET. What took it out? I don't know. I don't know. Leave your favorite leave your favorite reason in the chat. Oh, do the LEDs blink now? Yeah. Let's power it up. Yeah, let's power it up. All right. Good point. I'll get this probe out of the way. You can see that my setup is not, it's not optimized for repair, like Livestream repair, like Lewis Rossman. That's what he does every day. My bench is set up for just doing like basic Tagano microscope inspection and stuff. So, but as you saw, it's all here. Like, you know, I didn't have to go anywhere. I got my irons, I got my hot air gun. Right, so it's all happening. So, yeah, let's power this sucker up. Oh, I think it goes up the other way, doesn't it? No, let's go down that way. Hang on. Oh, I saw something. No, it doesn't flash. Look at that. Doesn't flash. And hopefully we haven't taken anything else out. There we go. Ta-da. It was, these LEDs were flashing charging before, weren't they? Still, the first LED's off. But, you know, who knows, right? Because we're actually missing a MOSFET. But there you go. It's not doing it anymore. So, yep. Yeah, I've broken it, yeah. Actually, that was, you know, in theory, right, and in practice, right, taking out that MOSFET could actually, like, take out other things. Who knows, right? So, yeah, you know, there's a non-zero chance that that MOSFET in there shorted was actually protecting other stuff, and then when you take it out, it's dead. Unlikely, but I don't know. There's got to be a scenario where that's possible. No, haven't fixed it yet. Have I got any spare MOSFETs? Let's have a look, shall we? Oh. Wah, 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 wah. I have no less than 3 MOSFET kits. Do you think any of them are going to be suitable? I've got MOSFETs, but they're all D-packs. They're all D-packs. I got through-hole MOSFETs. I've got TO220 MOSFETs. Oh, sorry, that's it. No, I've got 2. Sorry, I've got 2 kits. No, I've got bloody D-packs, right? Oh, jeez. Hang on. No, dragged a cable. That was the charging cable. Oh, by the way, for those who saw the repair of my sky projector thing, the star projector thing, I said in that I ordered an O-ring kit. Turned up. Yeah, I've got my O-ring kit now. Very cool. That's handy. So O-rings for watches and for I can properly repair. Yeah, it should, like, you know, because it's got 20 millimeters through to 30 millimeters. No, 1 millimeter increments from 16 millimeters to 30 millimeters. Nice, right? So I've got the exact, like, you know, it's great. And these cost next to nothing for these kits. It's incredible. So, yep. So yeah, unfortunately, unless I look through, I could go to my, I've got parts drawer. Yeah, it's a good thing those O-rings are in anti-static packages. Yeah. It's time for months in. Yes, we'll remove components until it works. Yep. Test the faulty lead. I don't think so. Oh, okay. I'll have to do that, though, using my Bryman, because the oh, come on. Because the virtual bench only has like 2 volt max output or something. So, yeah, it's pretty piss poor. 2.6 volts. But nothing's, oh yeah, no. 2.7. Yeah. Oh, sorry, you can't see it, but that one turns on. That one turns on. But that one does not. Yeah, I think we got a dead lead. What? What are the odds of that? What are are the odds of having a dead lead as well as a shorted MOSFET? Wow. Wow. I don't know. Anyway. Yeah, so like I could try and bodge. I can have a look at some of my kits because I haven't fully sorted all my kits. Because as I said, I usually keep project tubs. Like I've got tubs under here for different projects, and I generally keep all the parts for that project in that project tub. I don't put them into my generic thing. Let me go and have a look, see if I've got any. There's no point, Omar, to showing a thermal image anymore. We found it. We found the problem. So I don't know if you're watching like a, old version of the stream, which you can do. I did that once. I was watching, like last month or something, I was watching a Lewis Rossman stream. I was watching the Lewis Rossman live stream. He was driving or something, and I was commenting, and I was wondering why, like, you know, I wasn't getting a response, or I was getting a wrong response or something like that from the, and it was because I was like 10 minutes behind in the video. I didn't pull the bar right across, so I was actually behind. Yeah. Yeah, 30-volt P-channel MOSFETs. I was about to say that, Anton. In that I can salvage a part. Oh, did anyone check? Oh, did anyone? Sorry, I didn't see. Did anyone check Farnell's to see if that's available? Oh, look, I'll do it myself. Don't be lazy, Dave. Bloody hell. Element 14. Australia, not Austria. And what is it? A 4303, right? It's an SM4303. You might not put the SM on there, but let's try it. Nah, a rollerball quick connect. No. 4303. Nah. Nah. Do they have it on the DigiKeys or the mouses? Try the beta. No. Updates. No. Bugger off. Let's go America. America. Land of the free. Home of the brave. Nah. 4303. Nah. So it's, yeah, it's an oddball jobby, is it? Oh no, here we go. Through hole resistors. I'm not seeing MOSFETs. Am I blind? Am I blind? Hang on. Nope. Check DigiKey. Had no latch, David. Hey, signal path. Signal path in the house, people. I think you missed all the action. I think you missed the action, Sharia. Found a shorted MOSFET. You know, which I think is a quite unusual circuit configuration. I'd love to get the schematic for this, but I greatly doubt you'd ever get it. You'd have to reverse engineer it. I think they're doing some really clever switching in this thing. Yeah. I think it's really fascinating. Anyway, yeah, nothing, right? So 4303s. All right, so there's absolutely no, right, so there's no chance of, like, well, no, I'd have to find an equivalent. So we'd have to search for the parameters and everything else, right? But I could bodge in a DPAC. Like, there's no reason why I can't get one of my DPAC MOSFETs and bodge it in. But I probably won't do that in this video, in this live stream. I don't think I'll do it. Sorry. Yeah, like my other thought would be, yeah, I can, you know, take apart a laptop, or I've got other boards or whatnot, and PN 4303. Yeah, but that would have shown up. Oh yeah. Oh yeah. It's there. Oh yeah. There I got a what was it? NCP? Yeah, yeah. Yeah, okay. Yes, we can. Thank you. Whoever said that? Sean Yem. Thank you. Sean, there we go. Is he in his lab? Looks like he's in his lab there. Maybe. No, he's got a monitor in the background. Thank you, Sean. Yes, NCP 4303. Yep, there it is. Driver? Secondary side sink rectifying driver? What? No, hang on. No, that ain't right. No, that ain't it. Oh, yeah, no, I think I think I saw this when I was looking, when I was doing my repair video before, I was looking for the 4303 datasheet. Because I didn't know who the manufacturer was, because I didn't recognize the logo, the Sino Power logo. Like, you know, I just did not recognize that logo at all, right? I had no idea what that logo is, but I finally found it, and it was Sino Power, right? So it's that Sino Power datasheet we saw, and yeah, and I came across this. This is the thing I found, the NCP 4303. Yeah, I found this, and yeah, I realized no, it's not that. So then I knew that I had to search for the more obscure manufacturers, right? So that actually led me down the path. That's right. So yeah, but I eventually found Sino Power. I'm not sure how I found it, but I found Sino Power, and there's the logo. Here's the logo, the Sino Power logo. There it is there, Sino Power. I think they're Singaporean, or they were. Can somebody give me a fact check? If you go to sinopower.com, I think are they Singaporean? That's why they call themselves Sino Power. Sinopowersemi.com. Oh, here. No, I've got the Sino Power Semiconductor Inc. All rights reserved. English. Contact us. Technology marketing. No, they're a Taiwanese company. They're a Taiwanese company. There you go. Taipei. No, they don't have, not even real, no, don't even have a branch in Singapore. No, I was wrong. No, there you go. Stakeholder engagement. Fact sheet. Let's go to their stakeholder engagement fact sheet. Oh boy. Yeah, they're a Taiwanese company. They specialize in MOSFETs, IGBTs, and high voltage power ICs. There you go. Net capital, 333 million NTs. What's NTs? Chairman of the board, Tim Shu. President Tim Shu. There you go. We'll have him on the amp hour, and we'll go, why did your MOSFET fail? No, it's like, so why did this thing fail? There it is. There's a little bastard. Why did he fail? Don't know. You know, inadequate protection when they're, when the batteries are switching in and out. Because, as I said, there's complex switching in here. Oh, sorry. There's complex switching in here, and to switch it between like series for operation, I think of switches in series for operation and parallel for charging, or not only parallel, I think it's independent for charging. Charges one then the other, maybe they are in parallel, I don't know, but yeah, it's very interesting. Someone wants me to budget. Yeah. It's a unit of measure of value in China, is it? Oh, okay. Ah, right. Unit of measure of value in China. That's interesting. Okay. There you go. We learned something new here. I'm sure a lot of people didn't know that. I didn't know it. New Taiwan dollar. Okay. Thank you. There you go. NT. New Taiwan dollar. I thought it was... I knew they had the dollar. I didn't know they had a new Taiwan dollar. How new is new? See ya, Fred. Thanks, mate. Post the MOSFET to them with an angry note. Thank you, Anton. Check out that as a suitable replacement. Okay. Yeah. Yeah, I would be surprised if I can't get one of my, one of the ones I've got in my kit in a D-pack. But it's kind of not nice, is it, to budget? It's kind of, who thinks I should budget and who thinks I should get the proper part? Damn it. Wait for it. Finish your repair video with the proper part. In the chat, put bodge or proper. Bodge or proper. Budget. Bodge. Get the part, says Dave Pooh. He's a stickler. Christian's budget permanently, proper, with an exclamation mark, says Dr. Bodge. Vast majority. Bodger. Vast majority of people want the bodge. Oh no, there's no Exapod. No, you spam in the chat. Everyone wants me to fix it now. Damn it, now. I don't think so. I kind of want to. No, it's already 11 o'clock, and I want to. I don't want to go for the 3 hours today. I really don't. I would rather want to finish the video. Like, I'd rather get that repair video finished. So I think I will budget. I think I'll try and find. I'll go through every. Unfortunately, like the MOSFET kit I've got. Actually, this is not just MOSFETs. It's weird. Look, it's got an LM317 as well. I don't know. It's just one of these cheap eBay kits or whatever, or AliExpress kits. It's got some it's got LM317, 7805 and stuff like that. But that's got some that has some MOSFETs. Oh, sorry. It has some MOSFETs, and I'd be surprised. I don't know if they're all P channel or N channel or whatnot, and that's the MOSFET transistor kit. There you go. I could bodge in a TO220. I think there's room. Just put a bit of heat shrink over the tab. She'll be right. So yeah, otherwise I would have to go hunting in my other kits, in my generic kits. But generally, I don't think I have too many P channels. Like, the problem is it's a P channel. Oh, the LED might be a bicolor. No, I've never seen a... thank you, William. I've never seen a... No, it looks like a dual color. I've never seen it turn a different color when it's in operation, so it's always green. So yeah, I don't know what the deal with the LED is there. Have to do a MacGyver bodge. 2N56, 53. 2N50, have I got one of those? Was that there? No. Yeah, you know, but like, I think I'll try and bodge it if I can. I'll try and bodge it today because I would like to finish the video. I don't want to have to wait. Like, I don't want to have to, you know, get a part and then order the part and then a bloody courier's got to bring it. And, you know, like, I really don't want to have to do that. No, these at messages do not highlight. The only messages that highlight are ones that, yeah, there's Daveception going on. Sorry, I literally cannot get rid of this picture-in-picture. Like, I press picture-in-picture button. Off. It's still on. Right. Bloody Blackmagic ATEM switcher. Right? Unbelievable. Unbelievable. So yeah, like I've got a ton of old laptops. Some are like I think they all kind of like boot, but they're so old that, you know, I could use as a sacrificial parts unit. Yeah. So I think that'd be kind of cool, right? Wouldn't it? Who thinks I should do a salvage? Who thinks I should go to the effort, press Y in the chat, or no for not, if you think I should, if it would make a good addition to the repair video if I salvaged it from a laptop or something like that. I would say salvaged it from something. Would that be a good, should I go to the effort to go down to my storage unit downstairs, open up a bunch of laptops and see if they've gotten, like older ones, to see if they've got like an SOP MOSFET? Yes? 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 Salvage? Everyone says yes. Don't do it. Rassenbot. Ooh. But no. It's got to be 95%. Say yes. Salvage. Almost everyone. Yes, yes, yes. More educational, Mads Tech. No, there's a couple of people who say no. Okay. Sorry, Dave. Lead time is 4 months for your MOSFET. Yeah, that'd be hilarious. Actually, I might do two things in, like, assuming that this fixes it, right? Assuming it's done, right? Actually, the video is already like 12, 15 minutes long or something like that, or is that 20? I can't remember. Yeah, so I don't want to make it too much longer. So it'll be easy to find that MOSFET. Anyway, so I'll just add, you know, because that literally was my next step, was to suspect the MOSFETs, right? Well, no, the first was to suspect the charger IC, which I checked, and then it was to suspect the MOSFETs. Because the good thing with MOSFETs is you can measure them, especially if they're shorted, which seems to be the case here because it was draining the battery. So, yeah. But yeah, wouldn't that? Yeah, so there's two things I can do. One is to go on DigiKey and search parametrically to show people how you would search for a replacement, because this is this is an obscure part you probably can't get easily, right? Or you might be able to get it from LCSC or someone like that, right, in China. But yeah, this might be a good example where I can show, let's do a parametric search, see if we can find equivalent parts, right? And then have a look at the lead times for them and assume they're all out of stock, right? And then, yeah. Yeah. What are you talking about, Mick? Adds another 3 hours. Heinrich, thank you again, but I have said in previous live streams, please stop super chatting. And you've done it twice today. I appreciate it, but please. Yeah, fine. Fine. Okay. Because you did that, I will look. I'll go to eBay. But then it'll take forever to get here, right? That is the problem, right? SM4303. Yep, you are right. I can get it on eBay. There you go. Right? But it's got to come from China. Speed pack economy. Right? Monday, 28th of March. To Wednesday, 11th of May. Yeah, nah, as we say here. Yeah, nah. Oh, LCSC has 19 in stock. Yeah, that doesn't surprise me. Is it the Sino brand? See, I can put all of this, right, in my repair video, and I probably will. Like, I'll search LCS, I'll search DigiKey, I'll search LCS and the Farnell's DigiKey, LCSC, and then, you know, even eBay, I'll show that that's a thing. Yep, Sino Power, yep, yep. Yep, there you go. Sino Power do have them in stock. The LCSC do have them in stock. Yeah, there you go. 50 cents. So I can get an exact replacement. There you go. From LCSC. Cool. But I won't. I really like the idea of bodging something, I think. I think that'll make for a better repair video. RS, yeah, haven't searched RS. Rat shit components, yeah. I doubt it. Because I don't think there's another equivalent. I think this is a Sino Power part. Like, there might be some equivalent in China, but I guarantee you're not going to be able to get it, right? 4303. Because we've had it, like, if you can't get it on DigiKey or Mouser, then it's probably like an equivalent part. Then it's not a mainstream part, right? So yeah, 4303. There it is, right? No, there's just nothing doing. Nothing doing at all. So, yep. There you go. Ta-da. £23 for 100 pieces from AliExpress. Wow. 3-week lead time. Yeah. Yeah. Let's buy it, but budget. Why do we not make chips in Australia? Because our market's a nothing burger. Put random chips until it's fixed. No, yeah. The first thing I'll do is I'll search my kit. And see if there's an equivalent. Actually, I want to do this anyway. I'm going to go through every single one, and I'm going to at least put PNP. Like, if I'm going to go to the effort to check, then I'm going to write on the label, you know, PNP, you know, NPN, PNP, P channel, N channel, and, you know, and some basic specs and stuff. I should do that, right? I should go to the effort. A video dedicated how to find equivalents would be great. That's interesting, Mads Tech. Yeah, I think I've done it before, but I think you could be right. I think this could be a really good video in its own right, like a spin-off video. Who thinks this would be a spin-off video? Just like it only needs to be like, it'd be 10-15 minutes by the time I waffle on, right? But I can go, look, go and watch the repair video, right? Here's the intro. Go and watch. This comes from my repair video. Go and watch it, and then I can do that as a separate video. So I could spin off. Who wants me to spin off 2 videos from this? One or two? 1 or 2 in the chat. Should it all go into the repair video, or should I leave it out and make 2 videos, and then I don't include it in the repair video, and I simply point people to the second video? Yeah, I'm already thinking of the sequel. Yes, 2. No, I'm thinking they'd both be main channel videos. 2, 0 from Okerka. 3.1, Windows 3.1 from Timothy. The majority of people think I should turn it into 2 videos. Okay. Jaws 3, Rassenbot says 2. 2 birds, 1 stone, win-win. Yeah. Yeah, because if I look at all the alternatives, right? If like I'm just thinking about the video now, right? It'd start off with, this comes from the repair video. If you want to see the repair, go watch this video. I'll link it in, blah, blah. And then I would go, right, how do we start finding a replacement for this? Google search first. We find that, oh, we can't find it. Oh, no, this could be an interesting thing. This could be how I actually found the Sino part to begin with. I can't actually remember how, so I'm going to have to, like, you know, but I can actually record myself looking for it again, right? Googling it again, trying to find the actual Sino power, because I had no idea what that brand was. So it can be a combined how to find the manufacturer in the data sheet, and then how to find a replacement, all in the one video. And this is easily a 15, or even, you know, this is easily a 15-minute video. It's in own right. So if I include all this detail in the repair video, then the repair video is bloody half an hour, and it shouldn't be, right? So yeah, thank you, Mads Tech. I think I'm going to make 2 videos out of this sucker. Yep. Yeah, so, and, Big Clive does that sort of thing, does he? Okay. All of Dave's videos have a little YouTube rant in them. Yeah, and, yeah, perfect. Perfect, you think, Arson. Yeah, I think it's good because, like, there's a lot of things in this, and each one takes a couple of minutes to do, right? In a video. Okay, well, let's search Google for the part. Then, okay, we can't find it, and we turned up that data sheet that we got before, which was the NCP 4303, right? And then that, because I actually did find that. That's the first thing I found. And then it was a synchronous thing, and I went, that doesn't make sense. It's a MOSFET. I know it's a MOSFET. So then I think I put MOSFET after it. That's right. I think that's how I found it. I think I put 4303 MOSFET, and then I eventually found the Sino part. Yeah, right? So yeah, this has given me, yeah, my eyes are lighting up, right? You can see my, like, enthusiasm for, like, doing this, right? This is like, yeah, I love it when these things come up and then it gives me good spin-off videos, right? Yeah, because that's a video in its own right. How do you find that data sheet for that obscure Asian brand chip that you've never heard of and you don't know the label on them? And, you know, yeah, absolutely fantastic. Yep, I'm going to do it as a separate video. And so the repair video will just be, okay, we measured the MOSFET, we checked the chip, we got the waveform, so I think the charge in, go through the topology, how I think it's working with the series powering and the parallel charge in and everything, and how it must be absorbing a load, and not everyone has a thermal camera, so I'm not going to do a thermal camera, right, thing. You know, you could put it in that finger test, right, go around and test stuff. I'll mention that maybe. Probably forget, but right, yeah, I should have write all this shit down in point form so I know what I'm going to cover in the video, but I just wing it. And then yeah, like, and then next step, measure MOSFETs, because MOSFETs are easy to measure in circuit, and bingo, we found one that's shorted. Boom, let's measure the rest of them. They're all okay. Took it out, shorted. Bob's your uncle, right? And yeah, and hopefully that fixes it. I mean, you know, whether or not it kills it again, I don't know, right? But yeah, cool bananas, cool bananas. All right. And then, yeah, in the repair video, I'll try and get a bodge. I'll try and get a bodge for it. Yep. Thanks, Johnny. See you, mate. I might be out of here too, because otherwise it's 11 o'clock. I've already been here 2 hours, and if I stick around, I'm gonna do the 3 hours until lunchtime, when I should actually be going and finishing making these videos, right? So yeah, I'm gonna do that. So yep. So unless anyone has any last minute questions, I'm gonna call it quits for today. Is it just me, or is his voice sometimes garbled? Shouldn't be. You have your notes right there in the live stream. Just re-watch it. Yes, I do. I can re-watch my own live stream. Yep. So yeah, I'm going to go. Yep. Debunk full self-driving. No, I can't. You can't debunk it. Like all you can do is rant and have your opinion. It's not really a debunk. It's not, you know, you can just laugh at it, you know. Cheers from Ontario. Honk honk. Keep honking. Till that dude's gone. Omar, thermal camera afterwards. Maybe. Yeah, maybe. Yeah. All right, cool. Thank you, everyone. I hope you enjoyed that waffling on repair, which would have taken me, you know, 5 or 10 minutes in if I was actually doing it, right, rather than just dicking around on the live stream, and right. So yeah, if I was serious, it would have been, yep, charger chip, fine. Next step, MOSFETs, boom, found. Yeah, the end. Hopefully the end. Hopefully there's nothing else that's buggered, right? So yeah, so I'll try and bodge in a MOSFET from somewhere. That'll be fun. So I'll go, it's not lunchtime yet. I'll probably get burger and chips today. Be naughty. And I'll go get some laptops, I think, and maybe take them apart. No, first I'll go to my parts drawers, make sure I don't already have one, but I don't use many P channels. So I don't think, from memory, I've got many P channels lying around, let alone one that matches. Murphy will guarantee I don't have one. Then I'll probably go take apart some old laptops, you think? Because the new modern ones have bloody weird-ass little pissant packages in them. So yeah, I might, yep, hopefully. I'll just take apart some old laptops or something, see if I can salvage something. Although I've got a bin of other boards, but the odds of finding, like, no, the odds of finding a grunty, you know, power P-channel MOSFET like that, I think it's pretty low. I can always find faults in 5 minutes when I search 2 hours for them first. Yeah. Yep. Yep. Anyway, thanks everyone. Hope you enjoyed it. That was fun. We actually almost finished a repair, but yeah, I need to go find something, and that'll take a long time. So, yep. Catch you next time.